Okay, hey guys, it's Mrs. Gephardt, and I am going to be taking you through your notes today on the periodic table and determining the shells and the valence electrons. So you should have a worksheet, a half sheet, and we'll just kind of work our way through it. I did use this website. I just want to say this on the side that this is a website that I took from middleschoolscience.com, so just wanted to kind of throw out there and give some credit. So to start off, going through the PowerPoint, you're going to kind of fill in the blanks in terms of the information that is provided. I'm going to just come right here and get a pen. Sorry, I just want to play with that pen real quick. So what you see on here is periods, okay? So remember that periods are things that go horizontally, and they're all color-coded, as you can see. So each period, or each row is called a period. We went over that in class, so that should make complete sense. Okay, the elements in each period have the same number of shells, okay? And in terms of shells, I want you to think of shells, and we kind of did this in class, but you guys all watched me draw the little electrons around a thing, something similar to that. Those are shells, okay? So the period number equals how many circles I have to draw. So if I'm in period 1, it's 1 shell, or 1 circle. Period 2 is 2 circles, period 3 is 3, 4 is 4, 5, 6, and then 7, of course, okay? So the period number is equal to the number of circles or shells I have to draw. All right, the groups, and we remember that the groups are what goes up and down, so the groups are also going to have a different setup, okay? Each element in the group has the same number of electrons in their outer circle, okay? So if I have an atom that has, let's say, 3 circles, its outer circle, whatever element, if it's in group 1, it's only going to have 1 electron. If it's in group 2, it's going to have 2 electrons. Okay, now when we count the group numbers, we have to ignore the transition metals. Okay, so when we count them, it goes 1, 2, and it jumps all the way over here and goes 3, 4, 5, 6, 7, and then 8. Okay, if you look at the top of your periodic table, you will see Roman numerals, and it will go Roman numeral 1, 2, and then it goes 3, 4, 5, 6, 7, 8. Okay, I know in class we started and said it's groups 1 through 18, and that's still the same, but when we're drawing these electrons and we're drawing the placement of electrons, we ignore this center piece and we renumber them 1, 2 through 8. Okay, and that number, whatever group they're a part of, tells us the number of electrons in the outer thing. So we've got 1, 2, 3, 4, 5, 6, 7, and then 8. Okay, and we will be doing a lot more practice with that, so don't feel like you're going to be sort of stuck. The electrons in the outer shell are also known as valence electrons. That's another piece of information. They're known as valence electrons. So it's kind of a term that's going to come back up when we do a lot of the stuff that we do. And this kind of goes over at 1, 2, group 8 has 8 electrons. Except for He. He is going to be the only element within group 18 that does not follow this rule. So this right here, and I will explain that further in class, but that particular element is very special. It's not going to have 8 electrons in its outer shell because helium, let's go back and look and think of our periodic table, helium only has an atomic number of 2 with an atomic mass of 4. So that means that even though it's in group 8, and I'll explain why it's in group 8, it only has 2 electrons in its outer thing because its atomic number is only 2. Protons 2, neutrons 2, electrons 2. Okay, so this is the only exception to the rule when it comes to all of these groups. Okay, but just know that they're called valence electrons. You have to know that term, valence electron. So if I tell you this element has a valence number of 5, then I know that it's going to have to be an element found in group 5, which is 8, 7, 6, in this blue, lightish blue region right here that I'm kind of making all red, okay? All right, now the transition metals, and this is what we're going to kind of talk about. They have a lot of different rules, okay? They don't follow nice rules like those others did. And so this is why we're not going to do them. And I know I kind of joke with y'all in class about the fact that your transition metals, your high school chemistry teachers are going to go into, and they are. Because it's not necessary for you at this point to understand all of the different rules that they go under, okay? So don't worry about it. We're just not worrying about those particular elements. And that's a little note there telling you that your high school chemistry teachers will take care of it for you. Okay. All right. So now what we're going to do is we're going to turn our worksheet over to the back. And on the back side, and I don't want to just going to flash it real quick, but on the back side, you have a chart. Okay. And we're going to try to go through and determine the shells and the number of valence electrons. So we want the shells, how many circles we're going to draw, and then how many electrons are in the outer shell. Okay, so we first start off with carbon. So the first one is C, the symbol C, elements carbon on your worksheet. When we look for its period, it is in period 2. Okay, it's in period 2. It's going to have, therefore, 2 circles. All right, it's in group 4, which means there are 4 valence electrons, okay? So when I'm drawing out carbon, okay, it's got 2 circles. You see right here, this is pointing to those circles, so it's got 2 circles. And then its valence number is, because it's in group 4, it's got 4 electrons. That means I'm going to start with 2 in the center, because I always have 2 in this first area right here. And then I'm going to branch off into 4 more on the outer circle. Now I know this is a lot taking it in. We're going to do plenty of practice in class, but I'm kind of just giving you that understanding. So when we draw this, I've got 2 circles. My first circle is always going to only hold 2. It can't hold any more than that. We'll go over that rule in class, but this first circle can only hold 2 electrons. Because this has 2 circles, I know my inner circle it's got to be full. It's got to have 2 of them. Boom, boom. So my second circle, because I've got 2 of them, it tells me right here, being in the group 4, that I've got 4 electrons. Okay. Let's go to sodium. Okay, that's Na, so sodium. And this is why we wanted you guys to memorize your elements, because, you know, you're going to see just things like this, and you're expected to know that that's sodium. All right, so sodium, and we're going to draw out sodium. So here's sodium, okay. This is this would be classified as the nucleus, okay, so it's the protons and the neutrons. Sodium is found in the 3rd period, which means it's got 3 circles. So the first thing we do is we can draw out, and sometimes what you'll see, instead of a black circle like that, sometimes like in class, I'll just write this symbol Na, and that will represent my nucleus, okay? That's kind of up to you how you want to do it, but that's sometimes what I've done before, just because it makes it easier to do, okay? Sodium is found in group 1. So that means I've got 3 circles, okay, which is what we did, 1, 2, 3. It's in group 1, it's only got 1 valence electron, and that's right there. And we drew sodium in class. I showed that to you when we were talking about being reactive. This is why it's reactive, because it's got that 1 lone electron, okay? So now let's look at Ne. Okay, so we have to name this element, we have to look at the number of shells it has, and the valence electrons. Okay, so Ne is neon. Okay, and neon is very, very special. Neon is actually a noble gas. Okay, so if it's a noble gas, it tells you all right now where I should find it. I should find it in the very last group on the right. All right, it is in period 2, and it has a valence number of 8. Okay, so if I were to draw out neon, and this is going to represent my nucleus, I've got 1 circle, I've got 2 circles, and I'm going to change my pen actually to a different color just so we can see the electrons. All right, so I've got 1 electron here and 1 electron here, and this number right here tells me I've got 8 on the second circle. And that's what we want, okay? Because for this thing to be happy and full and content and have an A in science, this element, neon, has to have 2 electrons in the first circle and 8 in the second, and it does. So that's why neon is so very special. It's so very happy. It's so very good to go. It doesn't want to react with anybody else because it's full. It's got everything it needs. It's not searching for anything. All of its spaces are filled, and we can see that. So the first thing here holds 2. The second circle holds 8. Well, I have 2 and 8 filled. I'm good to go. Okay. You've got the remaining elements on your worksheet to complete. So we've got H, B, E, S, K, and H, E. So you're going to go through, you're going to do the same exact thing. If you've got any questions, don't worry. I'm going to get you through this in class. But this is going to kind of give you a start so when we go in class, it's not so foreign to you. Okay? Please actually go through and complete the rest of your table. It's going to help you tremendously when we're thinking about drawing like we're doing with this. Okay? And if you have any questions, again, ask, and hopefully, and I'm just filling in the information that I already did for you, but hopefully we can address them in class, and I will talk to you soon about it.